Okay, good morning to all, and thanks to the PerformFish partnership for giving me the opportunity to tell you what Uniud have done in this 5 years of the project, and with the hope of having also transferred a study approach for the fish industry. Okay. Why? The slide, no. Why? Okay. Allow me to introduce myself for those who don't know me. My history as a researcher began after a degree in animal production science and then with a PhD in aquaculture. At the beginning, my work focused entirely on fish farming, especially on breeding and feeding the larval stages of marine fish species. In fact, my doctoral thesis focused on the relationship between nutrition and larval quality of marine teleost, in particular gilded sea bream and sea bass. But at the end of my PhD, some pathological issue shifted my interest to fish pathology and histology as an investigative approach. And so, of course, the marine larval pathology was one of the areas of my research activity with Professor Galeotti. My interest and research activity concern fish pathology and parasitology. In fact, Parafish Control Horizon 2020 project was one of the last projects that Uniud was involved in. And in this case, we work on Amylodinium ocellatum. In addition, my expertise include also fish histopathology, and so in the PerformFish project, my history fit well with the requirement of the project, which was to find quality histological indicator for larval and juvenile stages of sea bass and sea bream. I must admit that as a zootechnician, having learned to see and understand with histology the effect of a nutritional or management choice has been very useful for my work, also managing an histopathological diagnostic survey for fish farmer, feed producer, and privates. Well, now you know a little more about me, and we can move on the first part of my talk. I would like to supply you a brief introduction on histology, and I hope I am not being too didactic or obvious, but not knowing the cultural background of each of you. This general part will be preparatory to explain you the Uniud activity in PFF project, in PerformFish project. Histology is a branch of biology which studies the normal microscopic anatomy of cell, tissue, and organ, looking at structures visible only with a microscope. And this is the counterpart of the gross anatomy, that is the study of anatomy of at the visible or macroscopic level. The histopathology, instead, is a branch of anatomopathology that studies the changes in the tissue, in cell and organs as a result of disease processes or insults, applying histological method, of course. And if you want to go into further detail, and so study cellular anatomy or ultrastructural anatomy, the tool is the electron microscope, using, of course, transmission electron microscope. Histology, while being a classical study approach compared to the current omics discipline, can quickly provide the condition of a tissue at a specific time, supplying us useful info on the effect of experimental variable or experimental events. And thus, histology can still be used as the only investigative method, but more often it is an essential component in multidisciplinary studies. Today, if you do a review of scientific literature that associates fishes and histology or histopathology, you find more than 4,000 papers. You can see some of them dry. That and this study use, of course, histology. More than the 40% involve a study on the effect of pollution, a very current topic in effect. About percent studies the effect of alternative diets or nutrition effect in different studies, and of course many etiopathogenetic study on infection agent are included. And so, as Jeffrey Wolf said, Jeffrey Wolf is a super skilled histopathology, an American histopathology, whose interesting seminar I have had the pleasure of attending in the past. And Wolf said, contrary to the popular rumor, histopathology is alive and well. But what is needed for the histological approach to be effective? What are the must-have for reliable and effective histological results? One of the most valuable skills for the novice anatomic pathologist to acquire is the ability to distinguish morphologic evidence of disease from common background findings, artifacts of slight depredation, and species-specific idiosyncrasy. Generally, that degree of expertise cannot be taught in a matter of weeks to months, nor can it be learned simply by rote through dedicated self-study. Instead, the path to proficiencies traditionally require initial broad-based training in comparative pathology, which is then followed by a steady and diverse caseload, continued education, and most notably, many years spent laboring at the macroscope. It is true, the often tedious work, I know something about that, of evaluating untold number of normal animals that pathologists attain the ability to reliably differentiate between disease and unaffected tissue. So we do not improvise as histopathologists, but years of study and practice are necessary. Furthermore, avoid misinterpretation, but most of all, misdiagnosis is indispensable to obtain a correct data. Misdiagnosis occurs when a morphological observation is considered incorrectly to be abnormal, or when inaccurate or imprecise terminology is used to describe a particular morphological observation. Experiences dictate that three most frequently encouraged causes of mixed diagnosis are inadequate tissue fixation, poor histologic slide quality, and of course a lack of histopathologic expertise. And so it's very important to have flawless tissue fixation, histological slide, and good job in the lab and skilled technician. And for our luck in the lab, we have Carla, the super skilled technician. And so a good histological technique involves, therefore, several steps, often some of which, such as tissue selection, sampling, and fixation, are done in field by vets or pharma technicians. So this operator should be prepared because the quality of their work will invariably be reflected in obtainable results. For the other step, the responsibility is generally devolved to a lab. Of course, they are equally important to the outcome. And so for post-fixation, cup, trimming, processing, embedding, sectioning, and staining in general, these steps are done in a histological lab, of course. For example, the PerformFish partner wrote a sampling manual. The title is Juvenile Quality and Growth Potential and Standard Operating Procedures for Sampling and Data Recording. Also for the histological, for histology involved in project, there are a protocol, but as we see in this picture, the guidelines given were not always followed, probably due to the inexperience of the staff. Here you can see, most of all in this picture, what I mean, of course. In order to obtain a good specimen, histological specimen, the fish tissue must be very fresh and immediately transferred in a fixative solution in order to avoid autolysis. A good fixation is the most important step in producing good histologic slides. A proper histological evaluation depends absolutely on an excellent tissue fixation. This procedure allows to stop cell autolysis, thus preventing the morphology, to preserving the morphology of the tissue and organ under study over time. It's possible to use different fixative solution, like formalin on Buen solution or Davidson. If you use this solution, it's necessary to remove the sample after 24 hours and transfer the sample in alcohol. It's for the appropriate fixative penetration into the sample volume should not exceed 1/10 of the volume of fixative within a specific jar. The correct ratio sample fixatives is 1:10, or at least 8 times their volume of fixative. In the picture, you can see some example. In this situation, the fixation is not correct. It's better to put in a bottle, in a jar, few fish, open the ventral line, and exposure the organ inside to the penetration of the fish active solution, or if the organ are removed from the fish, to put in, of course, in a bottle, and the quantity of the fish that is better is like in this situation. The correct time of fixation, it depends of the size of the tissue sample, of course, but in general, 24, 1 day or 2 days are enough to obtain the correct fixation. It's necessary also avoid to force damage, and so pay attention how to touch or handling the tissue. Another very important thing is that the thickness of the sample, it should be 4 or 6 millimeters thick, and if used directly the biocassettes, it's very important to not exceed in thickness, because the imprinting of the cassette on the sample could create some artifact after when the slides were prepared. For all the other steps, you will have to rely on a laboratory you trust, of course. For the processing, the staining, it's necessary a good lab, a good histological lab. When all steps, well, all the steps have been followed in the best way, this is the results. I believe that you also think that this image shows a very good histological preparation. And for the record, the image shows a subject of Sparicotyle chrysophyll, for those who did not recognize it. And so I would like to stress on a few points before to pass the other part of my speech, especially for the technician or vets that work in a fish farm, who collect the sample that then have to go be evaluated by histopathology. It's necessary to have fresh sample, optimal fixation, good lab, and skilled histopathology to obtain the results, the perfect results, using histology. Okay, let's now turn. I hope that this part is useful for all that work in most of all work in fish farm. Let us now turn to the main part of my speech on development of a histological evaluation system for the purpose of PerformFish project. Probably you know that the PerformFish project had a focus at the increasing the sustainability and the competitiveness of Mediterranean gilt and sea bream and European sea bass farming, a sector that has remained stagnant in the last year. The project included 9 working packages with different specific objectives. UNIU, the team, has been involved in the work package 2, which aim at improving predictability quality and sustainability of the hatchery phase and phase of the two target species, gilted spring and European sea bass. In particular, we are carrying out we were carrying out two research lines. The first was the evaluation of the expression of gene related to innate and adaptive immunity and stress response. And the second was the topic of my presentation today, was the detection of histological larval juvenile quality indicator or hallmark. This is the UniUd team during the year of the PerformFish project. Unfortunately, Valentina finished her postdoc and Dr. Becky now work in Taiwan. As I think you have realized, the activity of UniUd within the work package of this project were focused on adopting the histological tool in order to first develop an original system specific for the evaluation of gilted spring European sea bass larval and juvenile quality, able to promptly recognize health problem in a fish batch and provide indication about the causes of this problem that could be due to not optimal management practice. Second, identify which descriptor and value deriving from that system can be exploited as larval juvenile quality hallmarks. The tool we have developed is named the Multi-Parametric Semi-Quantitative Scoring System. The name helps to understand its basic features. It is multi-parametric because it involves an evaluation of more than one descriptor. And it is a semi-quantitative because it consists of scoring each descriptor. And nearly 3,000 larvae and juvenile of gilted spring and sea bass from 3 major European hatcheries were observed for scoring. And now let's look at them in detail. This evaluation method is semi-quantitative, which means that a trainer operator assigned a score to a phenomenon according to its magnitude. And it is a 5-point scoring system where 1 represents the normal condition or lack of alteration, and 5 represent the maximum extent of the deviation. To improve repeatability, which is a critical issue for this type of assessment method, the scoring criteria have been detailed. For some descriptor, the scoring criteria were defined quantitatively using image analysis software. And then the measures were divided to intervals corresponding to score from 1 to 5, as in the case of hepatocyte fatty accumulation. In a specific area, we calculate by image analysis software the white percentage, and then we find the correct rank for the score. For other descriptors, no quantitative ranges were determined, but precise descriptive criteria were established. For example, for the desquamation of the intestinal epithelium. And so for each score, we had supplied a perfect description. In this image, you can see the 6 organ district that we use for sorry, this is the 6 organ district for which we obtain the different descriptor, and so gills, liver, excretory system, the kidney, of course, pancreas, adipose tissue, posterior and anterior intestine. In the table, while in this table are summarized all the descriptor and the respectively score. For example, the gill are assessed for mucosal cell abundance, chloride cell hypertrophy and hyperplasia, and inflammatory infiltrate. The liver is assessed for hepatocytes, fat accumulation, and also, of course, for inflammatory infiltrate. The descriptor were selected because they are sensitive to management practice, and in addition are indicative of fish health status during the larval stages, larval and juvenile stages. There are 18 organ specific descriptor in total, and then furthermore, for each organ district, architecture is also scored. This descriptor is very important because it includes all progressive and regressive lesion, especially those not considered by a specific descriptor. And so, doing a quick calculation, it turns out that for each batch, 24 data are obtainable. So that is a huge quantity of data, especially thinking that 20 fish for age, for batch were evaluated. And so the scoring system of the descriptor was defined and put to the test. Our main goal was to provide results that would be transferable and immediated even for non-experts. So we thought about what was the most mathematically appropriate way. From the beginning, it seemed to us that the answer to our needs was a weighted sum of all descriptors assigned to the various organic district, resulting in an index that we named cumulative histological index. However, later we discussed with a colleague, most of all a friend. He is an expert in systems theory and systems biology, who confirmed the correctness of our choice and help us to finalize our formula. So we decided to summarize the large amount of data provided by the scoring system into a single value that would provide general information about the histological quality of larval batch. We actually obtained 2 values. The first is this one, The first one is used to derive the degree of histological alteration of an organ district, and this is index is named OCV, or organ condition value, is given by the product between the average score, of the organ descriptor and the architecture of the organ. I remember you that in architecture there are considered all the regressive and progressive alteration, pathological alteration. And the second is, and the most general, is the weighted sum of OCVs of each organ district multiplied by the weights assigned to the organs. Okay. Sorry. This is the weight, the organ district weight. And as you already seen in the past presentation, this index, the cumulative histological index, it is between 1 and 25, but we have set a threshold at 3.5. Value below 3.5 are indicative of perfect condition of the fish for both species Gilta cyprina and sea bass. Instead, the increasing key indicate that variously severe pathological changes have appeared, which may or may not be biocompatible, depending of course, on which organic district is most affected, and inferred from the different way of the organ in the key formula. Of course, this is the weight of the importance of the organ district expressed as a weight. After several virtual score simulation, the threshold was set at 3.5, of course, and it should be the alarm bell or warning for the fish being evaluated, and thus for, of course, for the fish farmer. So that action can be taken before the situation become excessively severe or irreversible. I remind you, as I mentioned above, the tissue qualities is essential for the successful evaluation. Although a skilled histopathology can, to some extent, recognize and compensate for wrongdoings in histologic preparations, not fresh or poorly fished specimen undergo postmortem lysis that partially or totally compromise analysis or lead to artifacts that make histologic evaluation difficult or impossible. I would like to stress again on the importance of impeccable histologic quality. It's not possible to see arrive in the lab the sample in this condition. Of course, it's not possible to have after the high quality histological slides. The semi-quantitative scoring system depends on the judgment of an evaluator, exposing the evaluation to some level of bias that can skew the final data and conclusion. Therefore, some precautions have been taken in order to constrain these biases. The risk of having judgment subliminally influenced by information from the study belong to the expert at every level. And so it's very important to start with the blind observation of the sample. And so in this way, it's possible to reduce this risk. In applying our scoring system, we decide to set the number of fish evaluated per batch at 20. The choice of this sample size was a compromise between the need to evaluate an adequate number of fish from a huge population, the larval batch, but at the same time to limit the diagnostic drift as much as possible. And so, in brief, before to move on the application of our semi-quantitative scoring system, our multi-parametric semi-quantitative scoring system has been specifically designed for the evaluation of marine larvae and juvenile overall histological situation, bias and poor reproducibility risk deriving from semi-quantitative method have tried to be overcome by applying blind sample evaluation, by defining detailed scored attribution and controlling the number of evaluated fish. The key, the cumulative histological index indicate the histological status of a batch and acts as a wake-up call for the farmer or for feed producer or other figure. The MSSS outcome can be used together or individually according to the purpose of the study. Let's see how our scoring system was applied. Of course, the main objective inside the PerformFish project is to identify a method to obtain information, useful information for the fish farmer, but most of all to identify some histological quality hallmark useful to transfer. A number of batches, I show you some step to arrive exactly to the results. A number of batches of larval and juvenile of gilded sea bream and European sea bass coming from 3 different European hatcheries have been sampled, of course, and delivered to our lab. Fish have been sampled at the 5 usual stages. The sample were fixed in blend and then prepared and processed according to the normal histological technique in our lab, of course. For the application of the semi-quantitative scoring system, we use always the slide stained with hematoxylin, with hematoxylin and eosin, but of course we use also other staining in some cases to confirm some particular histological configuration. The sample were observed under optical microscope, of course, and our scoring system was applied for all the difference for all descriptor and OCV between hatchery were assessed. The key results will be discussed with respect to the fish, the fixed threshold. The value are reported as mean plus minus standard deviation. And of course, we use a non-parametric statistical analysis to indicate some significant differences. It should be noted that the result that I will show, I will be discussed on the basis of the experience of the UNIUD group, and of course of the knowledge present in the literature. Since unfortunately, due to a confidentiality clause, the zootechnical parameter and the breeding, the farming data of the farm have not been disclosed to the partner of, or not completely to the partner of the project. I would like to remember you remember the picture of the sample arrived in our lab due to the bad fixation or the bad preparation of the samples. Some of these were rejected, in particular in two hatcheries, 25 or 24 sample were discarded, rejected, not submitted to the evaluation. Before analyzing the results, I would like to strongly emphasize the number of the sample histologically evaluated for hatchery. Around 3,000, a very huge number for a histological study. I remember also that some sample, in particular some organ district, was the most compromised due to the poor preservation or poor fixation, and so often excluded from the evaluation, in particular, of course, the anterior intestine. Well, okay. I start by discussing the key value of the three hatcheries calculated for each developmental stage, are shown in the bar graph, both for Giltan sea bream and European sea bass. As you can see, key value remained below the warning threshold in the first stage, with very small differences between hatcheries. This means that no serious pathological alteration were observed. And the alteration observed were biocompatible, of course, but do not mean the total absence of injuries or alteration. Unfortunately, we cannot analyze batch. It's not possible now to analyze batch by batch, and so evaluated specific pathological pattern. It would take too long time to do this, but things change for the juvenile, especially for Giltan sea bream. We have some alteration, but now I show you some situation. Especially for Giltan sea bream, the exceeding the warning threshold is for sure attributable to the biological specific of this fish species when subjected to zootechnical forcing, and of course to the effect of breeding system. We don't know if the system is open or closed, and so the resulting water quality maybe is affected for the method. For example, we assume that in some hatcheries, I think in two of the three hatcheries that we have the sample, use a RAS, the recirculation system, for reading larval and juvenile. and then you will see some picture that demonstrate this. There were some problems related to this system and on reflected quality of the water. Okay, let's go to analyze the data respect to the different considered organ, in particular using the key. We can start from the gill. Due to structurally poorly differentiation of the gill in the first two stages, first feeding and flexion, the evaluation was carried out on the three other stages. In general, the scores are low, so the various indicators considered are most normal or slightly altered, with some difference between the hatchery label with the color, but the situation related to the gill is quite normal. Of course, if you then I see you some in other image with OCV. In OCV, I remember you, we put all the alteration, regressive and progressive alteration. So if we have a possibility to analyze all the fish inside a batch, of course, some alteration are present. In particular, in general, in gilted sea bream, for example, the gill architect was scored higher than other, and the main histopathological feature found in the gill were epithelial hyperplasia with lamellar fusion, epithelial leaf in edema, like in this image, shrinkage of epithelial cell, desquamation, necrosis, and in some case bacteria presence in the gill. I also put out that in the same hatchery, water quality has negatively affected the condition, also or little affect the condition of European sea bass. It would, for example, it would be interesting to investigate what is the noxa of chloride cell hypertrophy, very well shown in this image, but also in this other image. You can see the hyperplasia and the hypertrophia of the gill epithelium, but also of the chloride cells, and analyze the OCV, in effect, in some case arrive over exceed the 3.5 threshold. And so explain the OCV explain well that in some cases for some fish there are the problem related to the gill. I remember again that in OCV there are considered all the pathological lesions. As for the liver, the only aspect worthy of attention always is the hepatocyte fat accumulation. In the image are show this aspect, both in gilted sea bream and European sea bass. There are some statistical differences between hatchery, but not particularly interesting. Instead, the absence of statistical difference in the juvenile, which were affected by a moderate liver fat accumulation, unfortunately underlie a common trend towards the technical forcing or nutritional imbalance, maybe excess of lipid in the diet. Therefore, in nuclear atypia, macrokaryosis and polykaryosis, spheroid presence, necrosis, and atypical hepatocyte vacuolization, where the main pathological alteration found in the liver, and you can see in this picture. In this picture, we have a slight fat accumulation, but are present cellular infiltration foci. And in this picture, you can see the some nuclear atypia. Maybe this aspect can be ascribable to the use of antibiotics or other toxicants present in the water, of course. OCV are relevant only for European sea bass. The OCV reached the 5 for this index during the flexion stages, and it was related to the severe fat accumulation in the liver. For what concerns the anterior intestine, the most interesting data concern gifted sebrine, and in particular the presence of inflammatory infiltrates in the lamina propria, mainly lymphocyte, as you can see in this image. Probably this inflammatory pattern has a nutritional derivation, may be attributable to plant sources or for protein or oils used in artificial diet. But in this other image, you can see the situation for some juveniles where the lymphocytic infiltration of the lamina propria was severe, and also the infiltration of the adipose tissue and the pancreas is very important. And in this picture, we only put in evidence the presence of macrophage engulfed with the cellular debris inside, and we use in this case the Schmor staining to put in evidence the lipogranuloma-like lesion were present in the lamina propria. For the okay.
Sorry, Paola, we have one question real quick. Sorry, can you just clarify for the 20 fish per group? Does that mean in a treatment of 4 replicates, it's 5 fish per tank?
5 fish for 5 fish for batch for batch, exactly, for batch, 20 fish for batch, because we have in the project many batch, not only one but many batch, and so we evaluated 20 fish for group for batch. Okay.
Perfect, thank you.
Because for histological evaluation, how many fish is necessary to try what this mean. Is not a few fish. In general, when I perform other evaluation, I use 3 fish or 6 fish. But in this case, we have used 20 fish for age for batch. Okay. 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 For the posterior intestine, the main alteration observed were intestinal ectasia, epithelial desquamation with rarely necrosis, and the presence of very abundant supranuclear vacuoles, both for the Ingiltad sebrine and European sea bass, as you can see in this image. It's normal to have in some degree the presence of supranuclear vacuole, but in this case the supranuclear are very big, and inside remain material more positive, and so like cheiroid or pigment like cheiroid or something like that. This aspect can be again linked to a food forcing or complexity when the larvae are not enzymatically ready to digestive to metabolize the diet. As you can see, is marked most of all more in hatchery is more marked respect to the other, but in this, for example, okay, but the key remain always under 3.5. So this aspect for the first stages, first feeding and flexion, this aspect could be used as a healthy histological indicator, in our opinion, of course. Okay, because no, is blocked, and then again, okay. With regard to this organic district, pancreas and adipose tissue, the alteration in European sea bass with some differences between hatchery are almost absent. Noteworthy, it's a similar and abundant presence of adipose tissue in the juvenile between the two hatchery. Also, this aspect may be related to a zootechnical forcing. Similarly, also in gifted Sibri, you can see the same situation in juvenile, okay, in the juvenile, but with some statistical differences between hatchery. Due to the specific biological characteristic of gifted Sibri, excessive deposition of adipose tissue characterized by hypertrophy and hyperplasia of adipocyte can induce inflammatory pattern even very severe. It would seem that in gifted Sibri, hypertrophy adipocytes are subject to multiply mechanical and cytotoxic stressors that induce the production of chemokine by triggering the recruitment and infiltration of macrophage in adipose tissue and activation of inflammatory signaling cascade that regulates cell death induced by stress. In this image, you can see the infiltration by acidophilic granulocytes. And in the southern picture, we can see a particular lesion. This lesion remember the crown-like structure in mammal, and the crown-like are composed by a dead adipocyte and macrophage around the adipocytes. This lesion, in our opinion, the steatitis with the presence of crown-like structure in the adipose tissue are important quality indicator. To take into account to improve food management and consequently the fish health. In this image, you can see other detail, in particular the crown-like structure. The crown-like structure, in our opinion, is an interesting histological quality hallmark. and very important because this lesion maybe suggest some alteration of the metabolism of the fish. And you can see also the OCV exceed 5, the value of 5. Okay. At the end, the architecture of excretory system was significantly altered in all hatcheries. Ectasia of tubules and urinary bladder, glomerulopathy, epithelia, desquamation, necrosis, granulomas presence, tubular macrophage aggregate. These were the most frequent lesion in both fish species, and you can see in this image the ectasia of renal tubule, and in this case the huge ectasia of ureter with inside the calculi. With the calculi. The presence and the size of renal calculi was found to be very important descriptor to demonstrate the presence of some water quality problem, either as quality of the water supply in the farm, maybe presence of the carbon dioxide or gas, or as water deterioration in a rearing system, when the reading system is RAS. There are some statistical differences between the hatchery, and we suppose that the hatchery B and C use a closed reading system, maybe, but we don't have any information about this. We can show you other image related to the lesion in kidney. In this case, we can see the tubular ectasia, some problem related to glomerular, and also the infiltration, another calcula in ureter, and we can see in that the OCV value exceed 3.5, arrival near to 9, in particular for the hatchery B. Okay, I am arrived to finish. What are the most useful histological indicator in terms of quality? What are the histological hallmarks to pay attention to? What all the data collected from the application of our scoring system tell us? What we derived made seem simplistic, because this scoring system tells us that the medium in which fish alive and their diet are crucial determinants of well-being, and both are managed by humans. Yes, because the water quality definitely causes some histological lesion, cause OCV to exceed the threshold value. The gill and the kidney are the two organs most susceptible to the water quality. The chloride, the hypertrophia and hyperplasia of chloride cells may be related to toxicant presence, for example, heavy metal or other, or infection agent also, but some parameter of the water can induce the hyperplasia and hypertrophia of this kind of cell, very important for the fish. And so also the presence of calculi in the kidney was for us interesting hallmark because tell us that the quality of the water in reading simple is not good, and maybe the presence of the gas, some gas inside, but in particular, maybe there was an increase of carbon dioxide. Anyway, since we do not know some important zootechnical and management data of the studied hatchery, we cannot establish with certainly the cause of some lesion, but based on our experience, we had formulated, of course, the hypothesis. Certainly, the cause of this alteration, in this case, concern liver, intestine, pancreas, and adipose tissue, are maybe related to nutritional or the diet management. For example, the hepatocytic fat accumulation may be related to zootechnical forcing, of course, but also in respect to the kind material or the diet, so the kind of the diet. The presence of supranuclear vacuole are important during the first stages of the larva, because the huge presence of this particular structure tell us maybe some problem related to unbalanced protein content in the diet or also technical forcing and so on. For example, during our evaluation, we identify in the crown-like structure in effect of about 30–40% of juvenile. In the mammal, they are called crown-like for the arrangement of the macrophage around the dead adipocyte. And also in mammal, these lesions are related to obesity and insulin resistance. In fish, they have never been described, and we are trying to characterize and investigate them further, because if their significance in fish is the same as in mammal, they could be an interesting marker of quality, most of all for gilded sea bream. Okay, finally, in this picture, we summarize what we think is useful as a quality hallmark and what factor the fish farmer should investigate and act to solve the problem, respect to this descriptor. Some final consideration, but just one consideration. Yes, we believe that histology is a current, powerful, and useful tool for assessing the healthy status of fish, even with fairly quick turnaround times. But at the risk of sounding excessive, I would like to remind you of the must-have, which is the synergy with the field sample prepare operator, the preparation, who must be trained, a qualified lab, and an experienced skilled histopathologist. It's also very important to have a good synergy between the knowledge and the skill of the histopathology, fish farm, vet, and the farmers in order to get reliable and useful histological results. Thanks for the attention. Sorry, but I'm very tired because the 1 week ago I have a COVID, in a severe form, and my voice, my head is not completely well. Okay, I would like, of course, to thank Valentina Pacoridge, that she worked with me during this project, and she is fantastic, of course.
Thank you very much, Paola. We had one more question regarding whether there's any specific publications on the research you've provided.
No, not at all, but we submit a paper, and in this moment the paper is under revision, the second revision, and we hope to have a publication in few time. I think the paper is in a specific publication for the PerformFish project in aquaculture reports.
Perfect. And I would add to that as well. Any publications that come out of this that related to PerformFish, they will be on the PerformFish website. We also have a community in Zenodo and ResearchGate. So if you search anywhere of those, yeah, they will be available.
Okay. Yes, we sent the abstract in the platform, PerformFish platform.
Yes. So yeah. So for anyone here looking for that, you can go to the PerformFish website to publications, and you'll find links for that once they're available. I don't see any other questions at the moment. Thank you, Paola.
Thank you.
I know you said you've been sick, but you were very clear, and it was.
Sorry for my English, not always well. So sorry, and more my voice. I have many mucus in my airway, and so some difficult to speak.
No, it was very good, very well received. Thank you everyone for attending.
Okay.
This will be made available on YouTube, and the recording will also be on the project website. And there will be a post-event survey sent to all of you, which will include an option to select for receiving a certificate of attendance. So thank you again. Thank you, Paola, again for this. For the great work.
Thank you for the attention. Thank you.